Hey guys, welcome back to my YouTube channel. Today I'm going to be going over some acidity ranking questions. And before we begin, if you like the video, make sure to subscribe. A lot of you guys are watching the videos but not subscribing, and I would greatly appreciate it if you guys did subscribe. Anyways, let's get back to the topic of today's video. I do have some practice problems here, and we'll be going through them. So, first problem here, right? So when you're doing acidity ranking questions, you want to look at the stability of the conjugate base, right? And you can compare the conjugate base if you know where your acidic hydrogen is, right? So in this first molecule, for example, the acidic hydrogen, I like to draw like a rectangle around them. That's how I was taught. The acidic hydrogen is on this OH right here, right? And when you remove that, it's going to become an O minus. So that would be the conjugate base. So if I were to draw the conjugate base of this first one, this is how the molecule would look. And the second one, third one, the acidic hydrogen is on the OH. If we remove it, it will become an O minus. That's the conjugate base, right? And then this last molecule here, that's how our conjugate bases would look like. And so you just want to compare the stability of the conjugate base. The more stable the conjugate base is, the more acidic the molecule will be. And as we can see here, so essentially there's these trends you want to know, right? So oxygen is going to be more stable than nitrogen, right? So a negative charge on oxygen will be more stable than a negative charge on nitrogen because it's more electronegative. In addition to that, if there was a bigger atom than oxygen with a negative charge, such as sulfur, it would be more stable than oxygen. So an S minus would be more stable than an O minus. In this first example, we don't have any S minuses, so our O minuses will be the most stable. And then of our molecules with the negative charge on oxygen, the ones with resonance will be the most stable because it'll be the negative charge will be resonance stabilized, right? And so we actually have this molecule here, and here. These are all resonance stabilized. And then of these two have a Br and an F attached. If you see a halogen attached to your molecule, halogens are good with the conjugate bases because they're electron withdrawing, right? And with a negative charge, you have too much electrons, you could say, and the halogens will withdraw that negative charge, making it more stable. The more electronegative the halogen is, the more stable, the more stronger the inductive effect would be. We call it the inductive effect. Therefore, in this, the most stable molecule would be the one with the F, because F is the most electronegative. It's pulling away the most, like it has the strongest inductive effect. Then up next is the one with the Br, that's the other one with the inductive effect. And then we have a resonance stabilized structure without inductive effect, so that's going to be 3. And now between these two, we're comparing the negative charge on the nitrogen and the negative charge on the O minus. The O minus one is stronger. It's more stable, so that would be 4. And then our NH would be 5th. Okay, so that would be our first ranking. Hopefully that made sense. And we'll move on to second question here. Let me actually zoom out a little bit. Okay, so second question. Here I'm comparing a O minus, and actually the acidic hydrogen is not on the S. We'll be actually taking it away from the carbon on the side. So yeah, this second molecule will actually have a negative charge on a carbon, right? Okay. This one we would have that because we take it away from the acidic hydrogen, or yeah, that would be the conjugate base. There's that. And then here we have an inductive effect. And yeah. Excuse me. So comparing these molecules, there's only one that's resonance stabilized. So usually resonance takes priority over all the other factors. So immediately I'm like, this molecule is the most stable, so that's my most acidic molecule, right? Next up, I'm comparing the O minus and the S minuses. The S minuses are actually more stable than the O minuses because sulfur is bigger than oxygen, so the negative charge can be more, I guess you could say it can spread out over a larger radius, I guess, if that makes sense. And so between these two these sulfur conjugate bases, only one of them has the inductive effect, the Br. So that Br is electron withdrawing, so it helps stabilize the negative charge. So this one on the right will be my second most stable. Then this will be my third most stable. And then here we're comparing the O minus and the negative carbon. Negative carbon is not stable, right? So our oxygen one will be 4, and then our negative carbon will be 5, right? Cool. So third example, we have these molecules here. And so ultimately, I see that I have two carbocations, or not carbocations, but I have some cations. This first one's an oxygen one, second one's a nitrogen one. In the conjugate bases of those, we would get a neutral atom, which is ultimately more stable than a negative atom, if that makes sense. So right off the bat, like these two are the most stable, right? Because once we look at the conjugate base, we're looking at a neutral atom compared to the negative atom. The neutral one's going to be more stable. And which one's going to be more stable, the OH or the NH? Like we've said before, the O is more stable. So I'm going to give that the 1. Nitrogen's going to get the 2. And after that, now we can look at our other conjugate bases, which will actually be negative charges if we were to remove the H, the acidic hydrogen. Here we would be looking at a negative carbon. Here we'd be looking at a negative oxygen. And lastly, over here, we would be comparing a negative nitrogen, right? So of these three, which one's number 3? Our oxygen's actually going to be number 3. Then our nitrogen's going to be 4. And our negative carbon will be 5 because it's not stable. Cool. So fourth example, I have another cation here. So immediately I'm like, that's the most stable because when I remove the H, when I look at the conjugate base of that, I'm going to have a neutral atom that's going to be very stable, whereas the other ones, the conjugate bases would be negative. So I'm going to give that the 1. And that one we were comparing that was going to be the O. This one we're going to have a negative O. This one we're going to have a negative a negative N, sorry. Another negative N. And don't get tricked by this O here, this oxygen. We're actually going to have a negative carbon in this. Okay, cool. Sorry. I'm going to grab some water. Okay. So we established that this first one is number 1 because it's a cation. Comparing these other ones, I have an oxygen negative here and 2 nitrogens and a carbon. So the other oxygen is going to be number 2. Then I have 2 nitrogens and a negative carbon. Carbon's usually the most, it's like the least stable if it has a negative charge. So now we're looking at these 2 nitrogens, the 2 conjugate bases of these 2 molecules, right? Of these 2, this one on the left has a chlorine. It's actually right here. And the one on the right does not. So the one on the left will have the inductive effect, which is good for our conjugate base because it will stabilize the negative charge. So this will actually be 3. This will be 4. And that will be 5. Okay, so last example. It's a similar question. So let's just look at what atoms we're comparing, right? The ones with the acidic hydrogen. So this first one, I'm going to have a negative carbon. Negative carbon again. Negative carbon again. Negative nitrogen. And negative O. So of these, the most stable with the negative charge would be my oxygen. So I'm going to give this the 1 over here on the right. And then the nitrogen would be the next most stable. So that's 1, 2. And then I have 3 carbons that I'm looking at. And actually 2 of them have the inductive effect, 1 of them does not. So this has no inductive effect. This has the Cl3 inductive effect. And this has the F3 inductive effect, fluorine. So as we said before with the inductive effect, they're usually halogens. The more electronegative the halogen is, the stronger the inductive effect will be. And thus you would have a more stable conjugate base if you have a more electronegative atom. And so between the Cl and the F one's the most electronegative, so it's going to be more stable. So this is going to be my 3. Then we have 2 molecules. One doesn't have the inductive effect, one does. The one with the inductive effect is more stable. So that's 4. And this is 5. And that's all. That's all the practice problems I have for today. I'm probably going to be making another video soon over some different OChem topics from earlier on in the semester. And that's because the final's coming up. If you guys want like a specific topic, just comment down below and I'll probably make a video over it. And make sure you guys are subscribing if you like the video, because I am pretty low on subscribers right now. But yeah, that concludes today's video. I will see you guys in next. I'll see you guys next time. Thank you for watching. Bye.